Now we're going to actually get to look at score data structures and see what they look like and how to make them. A score in Nyquist is a list of sound events. So here on the left, we see the schematic structure for a score. It's very simple, just events in a list. What's an event? Well, here things get a little more complicated. The schematic for an event is this. The event is a time and a duration and a sound. So what's a sound? All right, we have another nested list to describe sounds. A sound is an instrument, which is a symbol, name for a function, and a set of parameters in the form of attribute, value, attribute, value, attribute, value, until the end of the list. Okay, so that's the complete structure of a score. Let's look at this in a little more detail and see some concrete examples. Here's an example. You can see that this is a score with 3 sound events. Each sound event, remember, is a list of 3 elements: the time, the duration, and the sound. All right, each sound is an instrument, the symbol note, and then followed by attribute, value, attribute, value. Okay, not every score is going to use note as the name of the sound or the function to call. Not every sound is going to have pitch parameters and velocity parameters, but this is a good example. Now, there's one interesting extension to scores which addresses the problem of, can we consider scores to be sound events themselves? Well, if they are, then they should have a beginning and a duration, or an ending. And so there's a special sort of pseudo note event, or pseudo event, called score begin end. All right, and it has the general format of a sound event. It has a start time and a duration, which are both, but they're both 0. And what you would expect to be a sound expression is the special name score begin end, followed by the start time and the duration. Okay, so this is kind of a pseudo event. It's like an annotation that you can insert into a score, and it's meaningful to some functions that work with scores. So for example, if you wanted to splice 2 scores together, how would you find the end? This is how you find it. All right, what are instruments? An instrument is just a SAL or an XLisp function. And so the question is, how do we get from a sound expression, like the list note pitch 60 vel 100, how do we get from that to a function call? And so there are 2 steps. First of all, we need to understand how function calls can be represented by lists. This is a Lisp concept, but we're using it here for scores in SAL. And we need to talk about keyword parameters. So step 1, this list representation of function calls. So in Lisp, a function call is not represented or written the way that you've probably always seen function calls done in programming languages. In Lisp, every program is just a list, and you represent function calls by lists where the first symbol in the list is the name of the function. For example, here we have a call on pluck with 2 parameters, and the parameters are just the following elements of the list. Okay, it's very curious. Until you get used to it, it can be very confusing. But this is what a function call in Lisp looks like. And because we want scores to be data structures, we're using the same representation for scores. These parameter expressions can be numbers, which evaluate to themselves. They can be symbols, which are evaluated as variables, or they can be lists so that they actually represent nested function calls. Generally, we will avoid that because at least my assumption is you do not want to become a Lisp programmer, and the purpose of scores is not to represent programs, but to represent data. All right, the second thing that we need to deal with are keyword parameters. So instruments need to have keyword parameters in order for scores to pass parameters into them, because scores are represented in terms of attribute value, attribute value. So these are actually keyword parameter value, keyword parameter value. So here's how we might write a function as an instrument. This is just a normal SAL function declaration, except the only constraint is that all of the parameters are keyword parameters, pitch 60, vel 100. And then the body of this function can call on positional parameter functions like pluck, pitch, times vel times 0.01. Okay, and so now that we've defined note, we can call it as an ordinary function, like play note where the pitch is 72, call note where the velocity is 50 and the pitch is g3, and the duration, we haven't really learned about this operator, but this is the stretch operator, say make the duration 2. All right, so now we know about how to represent function calls as lists, and we know how we're going to pass keyword parameters from the score attributes. And so here's an example of an expression in a score. We write the list note, pitch is 48, vel is 45. This is equivalent to the SAL function call note of pitch 48, vel 95. And the whole sound event, remember, includes the starting time and the duration as well as the sound. So we could construct the whole sound event using an expression like this. And this is then equivalent to writing the function call note of pitch 48, vel 95 with a duration of 1.5. That comes from here. And we haven't learned about @ either, but this is the time shift operator. So we're saying we want all of this to start at time 3, which comes from the starting time in the score. So the score is just very directly translated into function calls. But the nice thing about scores is they really are data, and you can manipulate them as data, as we will learn. And just remember that now that we know how to represent a sound event, a score is just a list of these sound events.